Okay, second we'll do aldehyde review. For aldehydes, the ending is Al, so again, drop the E of like propane and say Al if you see the aldehyde functional group, which is a carbonyl with a hydrogen atom. This is the aldehyde functional group, and it's always going to be at the end of the carbon chain in order to have that hydrogen atom. So that's what you're going to have to look for and differentiate between that and a ketone, which is somewhere in the middle of a carbon chain. So the first example is a 5-carbon. So this is always going to be carbon 1, the one that has the double bond to O. 2, 3, 4, 5. And that's pentane, but we drop the E and put Al for the aldehyde. And it's always going to be on carbon number 1, so I don't have to number that. And then I just number the side chain, this methyl, as 3-methyl. 3-methyl pentanal. The second example has an alcohol group with it as well. You can see the hydroxyl and the aldehyde group. And in the priority functional group chart, the aldehyde wins. So the numbering always starts 1 here, 2, 3, and carbon 4. Remember, that's not carbon 5, so it's only a bute. That's only just the bond to the hydroxyl at the end. So butanal. And I don't have to number that, but I have to number the 4, the OH, and as the OH acting as a side chain rather than as the backbone of a functional group, it's not OL, it's hydroxy. Hydroxy is the side group OH. And that should all be in one line as well. But I just run out of room because this is our crazy version over here, so I need a lot of room to write that one. You can see we have a halogen, 2 halogens, so that's like a difluoro. We have an isopropyl group down here, and we have the aldehyde, and it's harder to see here because I didn't write the -H, but you have to be able to notice it if they don't write it in. Sometimes the textbook doesn't. So I would say number 1, 2, 3, 4, 5, 6, 7 is probably my longest chain because I could go 4 and then 5, 6. That's not long enough, and 5, 6. So it's a heptanal. Actually, no. And a 3, 5 fluoro, and I have to put the di because there's 2 of them. And then I'm at the 4 isopropyl. And I just put it in that order, like difluoro before isopropyl because of the alphabet. And again, that should all be in one line, no spaces or anything. And next we'll do ketones. So the functional group for ketones is R, so any carbon chain bonded to a carbon that has a double bond to oxygen and another carbon bond chain on the other side of it. So it has to be within the molecule, not at the end, because if it was at the end, this would be a H, and that would make it an aldehyde. So the first example is the smallest ketone you could get because it's a 3-carbon molecule. Any smaller and it would be in an aldehyde. And so that's prop, AN and ONE. AN for single bonds in my carbon chain, ONE for the ketone. And this one you don't have to number because it's only ever going to be on carbon number 2 with a 3-carbon molecule. This is a cyclic example, example number 2. So it's going to start number 1 here, 4 carbon atoms. So cyclo for cyclic because it's in a chain, or sorry, it's in a ring. And bute for 4, AN and ONE. And again, I don't have to number this one because 1 will always be on the carbonyl because it's highest priority, and I don't have any other substituents around it. Okay, and then the last crazy version of our example is this hydroxy and ketone in 1. And again, on the chart, ketone wins, so I'll start numbering 1 here, so that 4 is the lower number. If I went from right to left, then it would have been 1, 2, 3, 4, 5, 6, 7, 8 on that carbonyl, and that's no good. 7, 8. Okay, so that's a decane. And this time I do have to number where the carbonyl is because it's falling on carbon number 4. The cyclobutane, because there was no other substituent there, I just had to put the carbonyl on 1, but because there's other substituents here, I have to tell it where the ketone is going, so carbon number 4. And then my other substituents are those hydroxyl, the side chains, I mean, for whenever I say substituent, that's the same thing. And it's 2 and carbon number 3 that those side chains are coming off of. And I have to list numbers for every hydroxyl there. Even though it's coming off of 2 in 2 places, I write it twice. 2, 2, 3, and then tri for 3 of them, hydroxy for the side chain OH. And all together, that's 2, 2, 3, trihydroxy decane 4-one. And that's it.